Righto, so a bit of a video for tonight because I want to do some testing on those King's batteries because I'm not sure if I have an issue with the batteries or just some calibrations in the shunt. Now let me show you the problem I've got and how we're going to check to see where that problem is. Let me turn around. Let's go into the power shed here where the batteries are. And what we're going to have a look at, so these two King's batteries here. So we're going to have a look at the state of charge of those batteries. So the state of charge on those batteries is 80% state of charge. Now the system has not been running any load at all today. The loads got taken off that this morning. So it's been all day charging up and I cannot go over 80% state of charge. So what I want to have a quick look at here for a second is, let's have a look at the 24 volt charge controller. So we're going to make sure that we have entered the float mode in the charge controller, which means the battery's reached fully charged. So I'm just waiting for this to load. It is a very, very slow tablet, so I just got to bear with us. So I'm just going to jump over. That's how slow this is. There we go. So today we have entered the float charge. You can see every day we have actually entered float. So let's have a look to see. And we've had, do that again, we've had 5.5 hours of float. So it's been charged for over 5.5 hours, fully charged. So we know that the battery has got, get that off there. So we know that we've had the battery hit fully charged today, and we're only reading 80% state of charge. So what we need to do is we need to do a capacity test on those batteries. So what we're going to do, we're going to leave it at the 24 volt system for the moment. Normally you would do battery capacity tests individually. We're going to leave it at 24 volt. We are going to turn the inverter on because the inverter has been off all day. No load whatsoever on the batteries at all, which gave it a good chance to charge up and make sure they're full. So we know these batteries are full. So we're going to do a load test on the 24 volt side, see how many amps we draw out of it. Now, if we have a problem, then I can take them out individually and do individual load tests on that. So that is what I am going to do right now and get that done. So let's get into it. Right, so what I've done now is I've reset the shunt here. So I've zeroed out my values of the shunt. And I've also set my state of charge to 100%. So what I'm going to do now is I'm going to bring the inverter back on again. So it's going to bring the inverter back on. And in this line here, I've got this plugged in just to an electric heater inside the cabin here. So we're going to plug this in just in here. And we're going to start pulling a load. And what we're going to do is see how, come on, focus, there we go. We're going to see how much power we can pull out of these batteries. So we're drawing a current of about 28 amps. I want to go higher than I want to run it at about 0.5 C. It's about a 0.25 to 0.3 C. So let me go ahead and up that load. All right, so I've upped the load. So we're now drawing about 50 amps out of the batteries, which is a little bit under 0.5 C. It is 120 amp hour, so it's probably around about a 0.4 C roughly. Now here's the thing, for all you political correct people, yes, the correct way of doing a discharge test is done at 0.2 C, but there's not very much pukid effect, if any, with LFP batteries. So running it at around a 0.5 C discharge rate is really not going to make a huge difference. Not for this quick basic test that I'm doing, because we are linking them together in 24 volt running two batteries. So if one battery is slightly down, then it can throw our results out slightly. But this isn't the perfect test yet. I've got to do them individually. So let's go ahead and let's see how much power we can draw out of that system running that load, and let's see if we get close to our 120 amp hour capacity out of these batteries.
A few moments later.
Right, so we've moved into the cabin now just to make it a little bit easier. So we can see so far we've taken 50% out of the batteries. and we have taken out 54 amp hours. So there's one little problem there for a start. At 120 amp hour system, 50% of 120 amp hours is not 54, it should be 60. So there's a bit of a calibration issue showing there, but that's fine, that's easy. We can fix that in some settings later on. So we've got a nice stable voltage of 25.5. We've been averaging just over 50 amp draw continuous, and we're going fine. We've got about an hour left in the test to go. So let's see what we get out of it. So just clicked over 120 amps taken out of the batteries. So that is definitely a pass for those batteries for sure. We can see our battery voltage is dropping away, so we don't have much time left. We've got two alarms come up, low state of charge and low voltage alarms have come up. So let's see how much we can get out of this. So leave a comment below of how many amp hours do you think I'm going to get out of this system, out of these batteries, before either the inverter or the BMSs shut down. Okay, so there you go. 123, where's my finger? There it is. 123.4 amp hours before the inverter shut down. So let's go out and have a look at the inverter and sum up this video. So we come into the power shed here. We can see the inverter's turned itself off, and we have got, we'll get this to focus, we have got under voltage shut down. Has tripped on the inverter and shut the inverter down, so there's no power on the inverter. So, well, I am really happy with the results of that test. So what I'm going to do now is I'm going to summarize that up. I've got some chargers up here that I'm going to hook up and get these batteries topped up. We're just going to run those chargers from our 48 volt system here, just top them up a little bit from those batteries. But when we look, let me get my frame right. When we look at it, those batteries are definitely performed better than what their rating is. Now, the inverter shut down before the BMS on the batteries shut down. So technically there is a little bit more power left into the batteries, but the way that voltage was dropping, there wasn't very much left, and I reckon the BMSs would have been shutting down within about a minute of the inverter shutting down anyway, so the batteries were pretty well exhausted. Now, those batteries have been in service now for just on 5 months. They've been cycled every single day, and they've been cycled to around between 0.5 to 0.8 C, so around about 50 to 100 amp draw each time I use them, because we're running devices in the kitchen. They've been cycled every single day, and then bringing down to about 50% state of charge, and then bringing them back up again. So that gives you an idea of what they've been doing. So they've been working reasonably hard, and for the 5 months they've been in, I cannot fault those batteries. They have performed flawlessly, but they're only 5 months old, so it's still early to tell, but so far I'm giving the King's batteries the thumbs up.